You guys like to hear from the mayor? So would I. So we've got 3 more talks in this set, and they are 3 talks of pure geekness. We're going to start off with KiteBot, DIY wind energy. We're going to go to where databases are, the future of databases. We're going to talk on NoSQL, and then we're going to end on how robotics are revolutionizing the manufacture of ballpoint pens. So now I'd like to welcome up a Burning Man project mate of mine, Jeremy Calvert. Hi, I'm Jeremy. I'm going to talk to you about kite-based wind energy. This might sound far-fetched to some of you, but anybody who's flown a large kite can attest to the immense power of the wind. Plus, they can get up a lot higher than windmills, where wind is quadratically stronger and more consistent. But don't take my word for it. There's lots of groups pursuing lots of ideas, literally dozens. Here we see a couple light mill, kite gen. They either hoist the turbine up high with the kite, transmit the energy down electrically, or transmit the force mechanically through the lines. The general theme is that they're secretive and expensive. They're trying to solve big problems in automation from the get-go. KiteBot's idea is let's just do the opposite of that. Let's build something as simple as possible. Let's do it openly, invite community collaboration, and let's just use the same principles that a kiteboarder uses. It's been proven for years, which should be a long stroke reciprocating engine. So what that means is when the wind pulls hard, we let line out and we impart energy into the anchored system. And when it's not pulling as hard, we use some of that energy to reel it back in. So this is KiteBot. It's got 2 systems, a steering subsystem in the front there and a drive recoil system in the back. The kite lines go down to 2 spools. Now the relative angle of these spools is going to dictate the steering of the kite, much like a kiteboarder's bar does. Each spool is coupled both to a steering system, which we'll look at in a second, and to the center transmission spool there by a fly freewheel. Let's get this mixed up. So the steering system, we need to differentiate the relative positions from the net positions. So we use a differential gear or a planetary gear. Here the sun is the steering wheel, effectively, and the planet ring, all those planets are connected together, rotates, connected to the left spool and the outer ring to the right spool. You steer the sun one way, you steer the kite. So that looks expensive, but they're not. You can get them for a few bucks on eBay. They've been mass-produced since the 1930s as 3-speed hubs, the Sturmey Archer 3-speed hub. You get them, you open it up, you remove a lot of the pieces in that exploded view. This is an animation of both the steering in the upper left there, showing how the steering wheel adjusts the relative positions. And then in the bottom, you see that the whole steering system pivots based on where the wind is pulling it, so the spools are always lined up with the kite line. From there, the center spool has a transmission line wound around it, which goes down through the axle of rotation and out to this drive recoil subsystem in the back there. So the single interface is this transmission line, which pulls on the kite line and lets the kite pull on it. So the first part of that is the same as the bicycle drivetrain. If you replace that front spool with bike pedals and the purple chainring that you can't quite see with the back wheel of the bicycle, you have a bike drivetrain, and we're solving the same problem. You need some gearing. All the purple and yellow components always rotate clockwise. The generator harnesses the surplus and provides a resistive torque, which we'll use to pull the line back in. And the flywheel is the kinetic energy store, which we use to reel the line back in. So, that's weird. Okay, so then the green gears rotate in both directions because they're completely coupled to the spool. So they rotate clockwise as we're looking at it, and lines going out, we're imparting energy. When they rotate counterclockwise, we're reeling it in. So how do we do that? It's another problem with differentials. So we use another planetary gear. Also, I just like them. If you imagine the outer ring is spinning with the flywheel. With its moment of inertia, and the generator is dragged on the planet ring enough so it stops, it slows down and stops, then the sun ring goes backwards and we're reeling the kite line back in. Actually, with this gearing, we don't need the planet ring stopped. It can be going just 3/4 as fast or slower than 3/4 as fast, and we've got recoil going on. So this is an animation. When that freewheel up front engages, we turn those gears red, and we're actually imparting more energy into the flywheel. And the green, well, it's on the website. So what else? What have we not picturing? Well, we have an actual derailleur in that drivetrain, the bicycle drivetrain, but we'll use derailleurs all over the place. We'll freeze chains to provide tension so they don't slip off. And another really important thing to have would be some kind of kite-line guide so that we limit lateral stress on the spools. But also it's a great opportunity to have brake line adjustment because there'll actually be 2 lines going to each spool, which we can use to depower the kite like a kite loader does. That would be handy. So this is a list of the mechanical challenges. There's a lot of them, but the point is they break down into nice individual little mechanical challenges. And I think if we get enough people interested, we can knock these out one by one and realize a prototype. So to that end, yesterday I put this up, and I've been working on this for a while, but made it public yesterday and solicit advice and involvement. And if you're interested, I hope you check it out. Thanks.
Thank you very much, Jeremy. Our next speaker is responsible for the M